Hi guys, welcome to 6.1 where we're going to learn probably one of the most important lessons of the rest of this calc year. Today we introduce what's called anti-differentiation, which is, like it sounds like, anti-derivatives. It's basically the opposite of derivatives. So for up to this point we've just been taking derivatives. Now we're going backwards. So let's go over a couple vocabulary words first. Let's start right here. This symbol right there is called an integral symbol. Integral means the same thing, or to integrate means to anti-differentiate. I think we probably have two words because mathematicians are lazy and anti-differentiate takes forever to say, and so we came up with a shorter word. So anytime I say to integrate something, that's the same thing as doing the opposite of derivatives, anti-differentiate. So this symbol is called the integral. It's like a really skinny, tall S. And whenever we have an integral, like right here in this problem, we're going to have an equation inside that integral. That equation inside of it is called the integrand. And then the dx at the end tells you you're going to integrate with respect to variable x. Kind of like with derivatives, we could write it dy dx, and that told us we were differentiating in terms of x. Same thing with that dx. That tells you what you're integrating to. So with that, let's go through our warm-up examples. So right here, this is asking us to take derivatives, which is something we've been doing for months. So f prime of x, the derivative of f of x, for x cubed, we should know by now that's going to be 3x squared. Put the 3 in front and minus 1. Okay, so let's try number 2. F prime of x, so derivative of x cubed is 3x squared, and the derivative of negative 10 is 0. Now, right here, you should notice a problem, because remember, anti-differentiating or integrating is going backwards. So if I look right here at this problem, and I wanted to take the integral of 3x squared, so work backwards from 3x squared, would the answer be x cubed or x cubed minus 10? Because the derivative of both of those is 3x squared, and that's a problem. We don't like it in math for something to have more than one answer, more than one right answer. We don't like that. So here's what we've done. Let's look at it like this, number 3. X cubed plus c, where c is any number. So if I took the derivative of this, it would still be 3x squared. But now, if I work backwards, so the integral of 3x squared working backwards would be x cubed plus c, where c could be any number. Because like we saw with 1 and 2, we could have a number here that's just going to disappear when we take the derivative. So that plus c is kind of like a placeholder where it says there could be a constant here, any number. It could be 0, could be negative pi, it could be 32/4, it could be lots of different things, but there is a possibility of a number. So the short of it all is right here. This c is called the constant of integration. And it must be written as part of your answer when you're anti-differentiating. So anytime you take an integral, anytime you anti-differentiate, you should have a plus c at the end. Anytime you anti-differentiate, you should always have that plus c. And that allows for that constant that would go away when we take the derivative. In the next video, hopefully you kind of understand integrals now. In the next video, we're going to go over our first integral rules. So just like you had derivative rules that you memorized, now we have integral rules that you'll memorize.